In this next problem, we're going to give you 3 points, and we're going to ask that you plot the 3 points in the Cartesian plane. Then, from the 3 points, form a triangle ABC, and what we're going to do is use the converse of the Pythagorean theorem to verify that we in fact have a right triangle. Once we verify we have a right triangle, we're going to proceed to find the area of the triangle. So the 3 points that we're dealing with here are A equals -2, 5, B is 1, 3, and C is -1, 0. What we're going to do is plot these 3 points in a Cartesian plane, and if we do that, we obtain the following figure. And what you can see here is there's my triangle, and if we had to guess where the vertex of the right angle is, we would say it's at vertex B. Now, to verify that this is a right triangle, what we need to do is show that the length of the hypotenuse squared is equal to the sums of the squares of the other 2 sides. So we're going to use the distance formula to find each of the 3 lengths of the sides of the triangle, and then we use the converse of the Pythagorean theorem to show we have a right triangle. So for starters, I'm going to find the distance from A to B. To find the distance from A to B, that's going to be 1 minus -2 quantity squared plus 3 minus 5 quantity squared. 1 minus -2 is 1 plus 2, which is 3. 3 squared is 9. 3 minus 5 is -2. -2 squared is 4. So that I have the distance from A to B is the square root of 13. Next, we find the distance from B to C. To find the distance from B to C, that's going to be -1 minus 1 quantity squared plus 0 minus 3 quantity squared. -1 minus 1 is -2. -2 squared is 4. 0 minus 3 is -3. -3 squared is 9. 4 plus 9 is 13. So the distance from B to C is the square root of 13. Lastly, we need to find the distance from A to C. The distance from A to C is going to be -1 minus -2 quantity squared plus 0 minus 5 quantity squared. -1 minus a -2 is -1 plus 2. -1 plus 2 is 1. 1 squared is 1. 0 minus 5 is -5. -5 squared is 25. So I have that the distance from A to C is the square root of 26. Now, if you recall back to the figure, we were concluding that the distance from A to C represented the hypotenuse of our right triangle. So to show that this is in fact a right triangle, we would need to show that the distance from A to C squared is equal to the distance from A to B squared plus the distance from B to C squared. So the distance from A to C squared is the square root of 26 squared. The distance from A to B is the square root of 13 squared plus the distance from B to C squared is the square root of 13 squared. Square root of 26 all squared is 26. Square root of 13 all squared is 13. Square root of 13 all squared is 13. 26 does equal 13 plus 13. So, by the converse of the Pythagorean theorem, this is in fact a right triangle. What we want to do lastly is find the area of the triangle. The area of a triangle is 1/2 the base times the height. The base of the triangle can be thought of as the distance from B to C. That distance was the square root of 13. The height of the triangle could be thought of as the distance from A to B. That also is the square root of 13. So I get that the area of the triangle is 13 halves square units.